I started with a motor from a clothes dryer, which is actually only a 1755 RPM motor, and then I figured, well, how big an impeller can I spin with this? From building my small dust collector, I learned that backward curved fins are the most efficient. So I cut these out from a chunk of hardwood on my bandsaw and glued them down on a piece of plywood, and here's just testing how that'll work. Wow, that motor will actually turn it over. There is some wobble in the rotor. I have to figure out how to try and correct that. These two thingies here are for balancing the rotor because the plywood and the fins are not all consistent. Next I glued on the second layer and then tried spinning that rotor up again. Power consumption was down a bit from spinning just a paddle earlier. I want to make a spiral housing for this fan rotor here, and so I've laid it out approximately. I want this to be 19.5 centimeters in radius here, coming around to 26 centimeters. And I want that to increase evenly, so I've drawn a series of spokes and I've got 6 intervals here. So I take the 26 minus the 19.5 for the narrow end, and that is 6.5 centimeters difference. Now I divide that by 6, which means for each spoke I get 1.083 centimeters more. For each radius segment I'm going to set my beam compass to be somewhere between the two radii, and if I just draw a little arc here and an arc from here, that tells me from this particular point I can draw a curve that joins those 2 points up. The next challenge is how to actually make the spiral housing, and I made this one by cutting curved segments out of pieces that I cut from a 2x4. And I put a sort of tug and groove joint on the end of it, all cut with a bandsaw to join them together. And then I put it all together with some glue. The rotor fits a bit loose on the shaft, so I need to shim it, but I have to shim it on 2 sides, otherwise I'm going to throw it off center. So I'm going to use a bit of polyethylene vapor barrier, and hopefully that will fit in and tighten it. That seems to be okay for the moment. This pin goes where the key of the shaft is, and it just keeps the shaft from spinning. I'll figure out a more permanent solution later. Measuring the power consumption inside the enclosure, it's about the same as the rotor spinning in free air, although if I block the inlet, the power consumption drops by a lot. Next, measuring the airspeed with a pitot tube, and I get about 4 centimeters, and that works out to about 25 meters per second, or about 430 CFM for this fan. And also measuring the static pressure, and that is about 95 millimeters, and again you can see the power consumption dropping a lot. So building this blower has been a fun experiment, but I don't actually have a use for it.